the respiratory system explained in a way we've never seen before. Welcome to Biomed Explorer. In this video, I want to talk about the human respiratory system. In this video, I'll discuss what the respiratory system actually is, how air travels from your nose all the way down into your lungs, what happens inside the tiny air sacs where the real magic takes place, how breathing itself actually works, and the major roles this system plays every single second to keep you alive. So let's get started. What is the respiratory system? Most people think breathing is simple. Air goes in, air goes out, nothing more to it. But beneath that simple rhythm lies one of the most efficient exchange systems in the entire human body. So what exactly is it? The respiratory system is a connected pathway of organs and airways that stretches from your nose and mouth all the way down into your chest. Its main job is to bring oxygen into your body and push carbon dioxide back out. Every cell you have needs a constant supply of oxygen to produce energy, and every one of those cells produces carbon dioxide as waste in the process. Without a way to bring in the fuel and remove the exhaust, your cells would shut down within minutes. Think of it like a two-way delivery route that never closes, working quietly in the background, whether you're asleep, exercising, or sitting still reading a book. On average, you take somewhere between 12 and 20 breaths every single minute without ever having to think about it. And each one of those breaths is part of a non-stop cycle that has been running since the moment you were born. How air actually gets into your lungs. Now let's follow the journey air takes on its way in. Air first enters through your nose or mouth, where it gets warmed, moistened, and filtered before it goes any further. Tiny hairs and a thin layer of mucus in your nasal passages trap dust, pollen, and other particles so they never make it deep into your lungs. From there, air travels down through your throat and passes a small flap of tissue that makes sure food goes toward your stomach while air goes toward your lungs, keeping the two pathways from crossing at the wrong moment. Next, air enters your voice box, which is also where sound gets produced when air vibrates across your vocal cords. After that, air drops into your windpipe, a sturdy tube reinforced with rings of cartilage that keep it open no matter how you move your head or neck. At the bottom of the windpipe, the pathway splits into two branches, one heading into each lung. This is where things start to look like an upside-down T. Those two branches divide again and again into smaller and smaller tubes, thousands of them, each one narrower than the last, carrying air deeper into the lungs. Inside the lungs, the air sacs are where gas exchange happens. Here's something that surprises a lot of people. All of that branching eventually leads to over 300 million tiny air sacs packed into your two lungs. These air sacs are called alveoli, and they are almost unbelievably small, most of them thinner than a single sheet of paper and wrapped tightly in a mesh of even tinier blood vessels. This is where the actual exchange takes place. Oxygen from the air you just breathed in passes through the paper-thin wall of the alveolus and slips directly into the blood inside the surrounding capillaries. At the very same time, carbon dioxide that your blood has been carrying moves in the opposite direction, passing out of the blood and into the alveolus, ready to be breathed out on your next exhale. This entire exchange happens because of a simple rule: gases follow. They naturally move from areas where they're highly concentrated to areas where they're less concentrated. Your blood arrives low on oxygen and high on carbon dioxide. So oxygen rushes in and carbon dioxide rushes out, no extra effort required. The whole process takes a fraction of a second. Once oxygen crosses into the blood, it attaches to red blood cells, which carry it out of the lungs and into the left side of your heart, ready to be pumped out to the rest of your body. Meanwhile, the carbon dioxide sitting inside the alveoli gets pushed out of your lungs the next time you exhale, completing the loop. How breathing actually works, the mechanics behind every breath? You might be wondering what actually causes air to move in and out in the first place. Your lungs have no muscles of their own, so they can't inflate or squeeze themselves. Instead, breathing depends on a dome-shaped muscle underneath your lungs called the diaphragm. When you inhale, your diaphragm contracts and flattens out while the muscles between your ribs pull your rib cage up and outward. This combination makes the space inside your chest larger, which drops the pressure inside your lungs below the pressure of the air outside your body. Since air always moves from high pressure to low pressure, outside air rushes in to fill the space and your lungs expand. When you exhale, the opposite happens. Your diaphragm relaxes and rises back up, your rib cage settles back down, and the space inside your chest shrinks. That shrinking space raises the pressure inside your lungs above the pressure outside, pushing air back out. This entire two-step cycle, expand, then contract, repeats quietly somewhere between 17,000 and 30,000 times a day, depending on your activity level. During exercise, this whole system shifts into a higher gear. Your breathing rate climbs, additional muscles around your neck and chest join in to help expand your lungs further, and the volume of air moving in and out can jump from roughly 6 liters a minute at rest to well over 100 liters a minute during intense effort. That surge is what allows your muscles to keep getting the oxygen they desperately need when you're pushing hard. The three main jobs of the respiratory system. So now that we've covered the parts, let's bring it together. The respiratory system has several essential jobs that it performs every single second of your life. The first job is gas exchange. This is the core function, bringing oxygen into your bloodstream and clearing carbon dioxide out of it, keeping your blood chemistry balanced and your cells fueled. The second job is protection and filtration. As air travels down through your nose, throat, and airways, harmful particles, bacteria, and irritants get trapped, filtered, or coughed back out before they can cause damage deep inside your lungs. The third job is regulation and conditioning. Your respiratory system warms cold air and adds moisture to dry air before it ever reaches your delicate lung tissue, protecting those fragile structures from damage every time you take a breath, even in freezing or bone-dry conditions. And there's a fourth role many people never think about: communication. Air passing across your vocal cords is what allows you to speak, sing, laugh, and make every sound you use to connect with the people around you. How much air your lungs can actually hold? Here's a number that tends to catch people off guard. A typical adult's lungs can hold somewhere around 6 liters of air at full capacity, yet during a normal relaxed breath, you're only using a small fraction of that space, usually around half a liter at a time. That extra capacity sitting in reserve is exactly what allows you to take a deep breath before diving underwater, blow out birthday candles, or push through the last stretch of a hard run. Lung capacity isn't fixed for life either. It tends to peak in your mid-20s and then gradually declines as you age, which is one of the reasons older adults can sometimes feel more winded during activities that used to be effortless. The good news is that regular exercise helps slow that decline by keeping your diaphragm and chest muscles strong and your airways working efficiently for longer. It's worth briefly mentioning how important it is to keep this system healthy, since respiratory conditions remain one of the most common health concerns worldwide. Conditions like asthma, where airways narrow and become inflamed, and chronic obstructive pulmonary disease, where lung tissue gradually loses its elasticity, both interfere with the same basic process of moving air in and getting oxygen out. Even something as familiar as a common cold is really just your upper respiratory tract fighting off an infection using the very same filtering defenses built into your nose and throat. This is part of why doctors so often emphasize avoiding smoke, staying active, and getting fresh air, because so much of your long-term health depends on keeping this exchange system working smoothly. Wrapping it up, there you have it, the human respiratory system, a quiet, tireless network of airways and air sacs working every second to keep you alive. It pulls oxygen-rich air in through your nose and throat, funnels it deep into millions of microscopic air sacs, trades that oxygen directly into your bloodstream, and pushes carbon dioxide back out with every exhale. Your nose, throat, windpipe, lungs, and diaphragm all work together as part of this system to keep your body fueled, protected, and able to speak, sing, and breathe without ever having to think about it. The respiratory system may be something you rarely notice, but with every single breath, it's working hard behind the scenes to keep you alive. Thanks for watching, and Biomed Explorer uploads a new science video every day. Please subscribe and share.